Okay, here we go. We are going to do some boards. Go up, please. Same type of thing that we've been doing recently where I give you a problem. I'll read it out loud so that you can um, understand what I'm asking you, because sometimes it's easier to understand it verbally. Um, and then I want you to hit pause. I want you to try it, and then hit play. I'll show you the answer. Once you get a chance to look at the answer, if you got it right, if you did it right, then you can just move on to the next part of the video. I'll put timestamps in some Google Doc or something for you. Um, and then um, if you didn't get it right, or you just want to listen to me talk through it, then you can listen to my explanation. So first one, given this vector field, 3 plus 2xy comma x squared minus 3y squared, we want to show that it is conservative. So go ahead, hit pause. I'm going to flip to the answer. Oops. I'm gonna do it this way. It doesn't matter that much. All right, so we do the curl. I calculate the curl of f, which is n sub x minus m sub y. So I partial this with respect to y. That gives me, with respect to x, this term goes away, gives me 2x for that. And then for this one, I partial m with respect to y. Well, this goes away, and then the 2x is treated as a constant, so the y goes away. So I get 2x minus 2x, which is 0, and that tells me that this thing is conservative. So let me move this down out of the way. Part B is to use a parameterization. Using a parameterization, I want you to find the integral of f dotted with dr, where c travels linearly from 0, 0 to 2, 4. So here's another spot. You're going to pause it. You're going to try it. All right, I'm going to show the solution. It'll fit. So I got 42. Sorry, negative 42. If you got that using this method, right, you used 2x as you did y equals 2x, or you could have used t's, then you're good to go. Remember, I didn't want you to use fundamental theorem for line integrals. I wanted you to do it with parameterization. So if you got that negative 42 using a parameterization like this, then you can go on to the next one. If you want to listen to me talk about it, then here we are. So I got 0, 0. I've got 2, 4 here. What is the line, because it travels linearly, that goes between those two? Y equals 2x, and x is going to go from 0 to 2. That's my parameterization. You could have x equals t and y equals 2t and use a parameterization with t, and it would get you the same answer. Almost everything down here would be the same except for like this line right here. All of the x's would be replaced with t's. Anyway, either way is good. I'm doing it with x's. So y equals 2x, x goes 0 to 2, and then this is the differential of that line up there. dy is going to be 2 dx. So I'm doing the integral of f dotted with dr. Remember, r is x comma y. So that means that dr is going to be dx dy. And then this f is just the force that we had up top, just copied in there. So I've got 3 plus 2xy, comma x squared minus 3y, dotted with dx dy. So the first thing I'm going to do is convert everything over to x's. I'm using these conversions right here. Anytime I see a y, I'm going to replace it with a 2x. Anytime I see a dy, I'm going to replace it with a 2 dx. So, for example, this y right here became that 2x right there. This y squared is now 2x squared. Make sure you square the entire 2x, not just the x. So, and then the dy gets replaced with a 2 dx. And now I can write my integral from 0 to 2 because I've got x's and dx's everywhere. So the next thing that I do is what I do. I did my dot product. So I looked at this, and this was a 2x times 2x, which gave me my 4x squared. This is my 3 right here. That got multiplied by the dx. And then I took the 2 here and multiplied it by this whole term. So that's this 2. X squared is the x squared. This mess turned to a minus 12x squared because it was 4, because that got squared, times negative 3. So I get this. And then the dx just kind of like stays on the outside of the dot product. From there, um, I can combine like terms. I have minus 18x squareds, and the 3 is there. I integrate that from 0 to 2. So I do power rule, 3x minus 6x cubed, up this by 1, and then divided 18 by 3 to get the 6, and evaluate that. This is nice to evaluate because the 0 there just zeros the parts of the polynomial, and I get negative 42. So hopefully that's good. Let's see if I can get this. Okay. Okay. Part C, I'm gonna put it a little bit higher up on this the video for you. Um, I I'm saying let f equal del f for some f of x comma y, and find that f of x comma y. So we can do this anytime we have a conservative vector field. So go ahead, hit pause, see if you can do that. I don't want you to just like guess it. I need you to show the work that we've talked about in class quite a bit about how to like integrate one and then derive it with respect to something else, blah, blah, blah. All right, so go ahead, try it. I'm going to show the answer. All right, so you could do it in either way. I'm going to integrate, let's see if I can find. All right, so here, there's f right there. This guy right here. This is my m. This is my n. So I'm gonna treat my m here as f sub x, the partial x of this thing, because that's what a del f is. Del f is partial x comma partial y. So that means that f, big F, is partial x comma partial y. So I got to integrate this with respect to x, right? F is the integral with respect to x of this thing, which gives me 3x, that's this piece. And then this, I integrate the x part, and I treat y as a constant. So that gives me x squared y plus some constant with respect to y, right? So it's all y terms, there's no x's. From there, I know that n, this piece right here, should be f sub y. So f sub y is partial y of f, which is partial y of this thing, right? So I take that thing and I derive it with respect to y. That's what I'm doing right here. The 3x goes away because there's no y's in it. And this gives me x squared. So I get x squared plus c prime of y. Now this is where it's partial y, and I match this with the partial y that we have here. Okay, because remember, we want f to be the partial y. So remember, f sub y is n. So I'm going to take this, which is my f sub y that I've just found, write it right there, and then write the n part component of the vector field here. And this allows me to solve for c prime of y. X squareds go away, gives me c prime of y equals negative 3y squared. And then I can integrate that from here to here and get y cubed plus a constant. From there, I take this line right here, and I sub in the c of y that I found there. So I get 3x, that's this, x squared y, that's this, and then this gets replaced with minus y cubed plus a constant. So that is how I answer that question. Okay, so Last part of this question, use the FTC for line integrals to evaluate the integral of f dot of dr with from part B. So I can use the potential function that I found in part C. That's what f is. Go ahead and do that. Hit pause. I'm gonna flip to the answer. One, you can see the answer is negative 42. I should, if I've done all my math correctly, get the same answer that I got in part B. So this is just it's the work here is a lot less than the work that I showed up there, but I had to have done this right here as well. So what is it? It's the potential function evaluated at 2, 4, the ending point right there, minus the potential function evaluated at the starting point, 0, 0. So in this case, I get f of 2, 4 minus f of 0, 0. So I evaluate this thing at 2, comma 4. It gives me 3 times 2 plus 2 squared times 4 minus 4 cubed minus the polynomial gets evaluated at 0 to give me 0. You may say, what about the c? Well, inherently, this guy's going to have a c, and this guy's going to have a c, so they're going to get subtracted out. And I get negative 42. So it's good. When I did this problem myself, I got the negative 42, and I was like, sweet, I've done this correctly. So hopefully you feel good with this. The next video will be another problem really similar to this. So maybe in the next one, you can, if you had trouble with any of these, you can try them and cross-reference your notes on what you took here and see if you are good to go.